Okay, good morning. Welcome to
KidMath106.
KidMath106. So today we're still in the section about functions, and I thought it'd be fun to spend a couple days talking about the Fibonacci numbers and how they're defined by a function. Do you remember how that function goes? We haven't talked about this in a while, but maybe you remember.
Well, 0, 1, 1, 2, 3, 5, etc.
Yep. And what's the relationship that how you figure out those numbers?
Well, the next number, this one, is the sum of these two.
Okay. Very good. So we'll call the relationship, we'll say, we can write it like this. Fibonacci, the nth one, equals Fibonacci n minus 1, the one that comes before it,
Yeah.
plus what?
Plus the one that comes before that, too. So f of n minus 2.
F of n minus 2. Okay, so this defines a function that we call the Fibonacci numbers when we start with f of 0 equals 0 and f of 1 equals 1. Okay, and let's see how that works. What is f of 2 going to equal?
F of 2 equals... It's going to equal f of 1 plus f of 0, which just equal 1 and 0.
Very good. So what
So-
does f of 2 equal?
1.
1. Okay. Which is just what you wrote down, by the way. Now, I'm starting with 0, 1. You started with 1, 1. It doesn't really matter where you start. So we have 0, 1, 1. F of 3 equals f of 2 plus what?
Plus 1, or f of 1.
F of 1. Okay, and what does f of 3 equal now?
F of 3, well, f of 2 is just 1. F of 3 is 2.
Okay, because f of 2 is 1. F of 1 is 1, so f of 3 is 2. And we can go on calculating. Just like you said, we just add the next two. So 1 plus 2, the next one's going to be 3, the next one's going to be 5, the next one's going to be 8. But if I asked you to calculate for this function, what is f of Fibonacci 100, or f of 100, that might be a little hard.
Gonna get big.
You're going to get big. Okay, and so we would have to do a lot of calculations.
You can just start to whittle it down to...
Right, there doesn't seem to be any obvious way to just calculate f of 100 without calculating f of 99, f of 98, all the way down, to here, right? At least not right now. But this is what we're going to talk about over the next couple days. I thought it'd be really fun to show you that you can actually write down a formula for each one of the Fibonacci numbers. And it comes from a very simple idea that if you graph these Fibonacci numbers, f of 0 is 0, f of 1 is 1, f of 2 is 1, f of 0, 1, 2, 3, f of 3 is 2.
It's 0, 0, 1, 1, 1, 1, 2, 2.
0, 0, 1, 1, 2, 1.
Yeah.
3, 2.
Okay. So it...
4, 3.
4, 3 up there. Then
5, 5. Okay. We have something that's going up and up and up.
it's gonna go up more and more steeply.
It is going to go up more and more steeply. In fact, it looks like a special kind of function called an exponential function, and we'll talk about that tomorrow. Okay. So this is what, sometimes you see functions just defined like this, without f of x's or anything like that. They're defined on what comes before them. And that's how the Fibonacci numbers are defined. By the way, you get a completely different sequence of numbers if you start out with something different. Like if I could have said f of 0 was 2 and f of 1 was 7, and we would have got a big sequence of, a completely different sequence of numbers, right?
Yeah.
And there was no way from the formula to tell what f of 0 was and f of 1 was. You had to just say I had to tell you what they were.
Yeah, they're defined like that.
They're defined like this because I could define them differently and I wouldn't get the Fibonacci numbers, right?
Yeah.
Okay. So this is going to be fun, and you're going to see a surprising appearance of the square root of 5. somehow these numbers, 1, 1, 2, 3, 5, 8, 13, 21, are related to the square root of 5. So this will be a fun couple days, all right?
Yep.
All right, good job this morning, then. Good job.